Hi, welcome to Sports Lab's webinar on FIFA product updates. Today we're going to discuss the changes with regards to the handbook of test methods for football turf, the tolerances and the test protocols in the most recent manual, and how they will affect product testing going forward. Today we're very lucky, we have Craig Melrose, the laboratory manager. Craig's got over 10 years experience in the laboratory. My first class honours graduate in sports technology, so we're in safe hands, and Craig's up to date with all the changes. We do a lot of the product testing, probably the lion's share of the product testing, so as a lab we're one of the biggest in the world, so you're in safe hands with that regard as well. A quick caveat, this is a rerun of our webinar from Friday, just to take a few of the delays in the slide out the equation. So the webinar will be downloadable from sportslabs.com, and our staff and myself, Neil McPhee, are also fully available to answer any questions post-webinar. So I will hand over to Craig now, who will take you through the presentation.
Thanks, Neil. So yeah, as Neil's introduced, we're going to cover the changes to the FIFA requirements and test methods that have been implemented over the last 6 months or so. All of these changes are shown here on this contents page, and we'll cover in more detail throughout the webinar. One of the most significant changes has been regarding peak breakage force. So this is the new name for what was effectively yarn tensile strength previously. As you can see, the grayscale colour change requirement on yarns still remains the same. However, a new method of comparing the individual yarns to the rest of the yarns within the same family or group has been implemented. As you can see here, the new requirement is that the percentage change from the green reference unaged yarn filament is to be no more than 25%. In the case of more than one green yarn, which is very common, the highest peak breakage force has to be used as the reference yarn. On this slide, we have a worked example of this new method and requirement. To start with, we identify the reference yarn that will be used for the calculations. As you can see in this case, the dark green yarn has been highlighted. Now this is the highest unaged peak breakage force, out of the two green yarns. Therefore, this is chosen as the reference value. We then check that each yarn after UV exposure is within 25% of their initial unaged values, just as previously done over the last 5 years or so, except with a lower requirement of 25%. As you can see, all of the yarns satisfy this. However, when you compare the peak breakage force results for each yarn after aging to the green reference yarn, then 2 of the yarns fail to meet the requirement variation. In this case, the blue yarn and the olive green yarn. When you look closely at the data, the unaged value of the blue yarn is already 12.5% lower than the reference. So you're already starting off with quite a change. So it doesn't really allow for much of a drop in the tensile strength after aging. Therefore, with this new scenario, I'd suggest that everyone reviews the peak breakage forces of all their existing yarns to check compliance. Any yarns that don't meet this new requirement will have to be retested, unfortunately. If there's any questions on this or anyone needs more detail on the worked example, please feel free to give me an email or a phone call at any time. Just a quick note on the line colour testing procedure for products. As of March, it's no longer necessary to run Lisport XL tests on line colours. We do still have to perform full carpet IDs, including unaged and aged tuft withdrawal on each line colour. The good news is that lines only need to be tested once for a specific model or stitch rate of carpet. For example, XY turf, with 14 stitches and a 5/8 inch gauge only has to have the full ID and tough withdrawals completed once. Then on the FIFA portal, a line product for that can be added, for example, for the white product, which will include the declaration information for that white carpet, plus the laboratory ID results. Within this new report format, there is no facility to declare shock pads or infill, which is why this report will be able to be used across all products in that family with different pads and different infills. One of the other major changes has been to the tuft withdrawal requirements. The test method is fully detailed within FIFA test method 26. As you can see, the requirement has increased from 30 newtons to 40 newtons minimum. This new requirement applies to both unaged and water-aged carpet samples, and for both FIFA Quality and FIFA Quality Pro levels. The test method has been adapted, so previously it just detailed following the method described in ISO 4919, but as I say, it's now been adapted to primarily to set the extrusion or extension rate of the apparatus to a constant rate of 100 millimeters per minute. We have found that this can reduce the tuft lock value of some products in some cases. This does apply to all newly certified lab products from the 1st of June this year, 2020. However, existing products are still valid, so anything that has been certified before 1st of June with a tuft withdrawal of higher than 30 but less than 40 is still valid and can still be used as a product. However, any turf products that are already certified but need to be recertified on a new pad or infill will require changes in construction or materials to increase tuft lock, or at the very least new samples submitted to check compliance. Another small but important change in one of the methods is for the measurement of yarn dimensions. So basically, a more detailed guidance has been given on how to determine the measurements of complex yarn shapes and what should and should not be identified as the material thickness or the overall depth of a shape. Figure 63 in the Manual of Test Methods has been updated to show an example of a more complicated yarn shape, detailing how the overall depth and width of a yarn is measured, as well as the thickness of the material, i.e. the largest diameter circle that fits within the surface area of the end profile of the yarn. It's this value that must be used as the declared yarn thickness. The depth value, as you can see on the left-hand side of the lower image here, is not the thickness of the yarn and should not be declared as such. Again, if there's any questions on individual details, please feel free to give me a call or an email at any time. The next couple of slides will cover some short comments on using the derivative function to identify additional peaks on DSC graphs, particularly of polymer blend yarns, obviously. Where the melting points of the different polymers are very similar, the peaks tend to blend or superimpose each other, making it difficult to correctly identify where the peaks are. It's in this situation that a derivative function can be used. As you can see in this image, the derivative has been used to better identify where the shoulder or the peak is. The black outline of the DSC curve does show a shoulder, but by using the derivative or imposing the red line on the graph, the exact peak or melting point of 115 degrees has been identified. It is important that all melting point or points or peaks are correctly identified to check the yarn materials from the field match the product report. Another change to the manual has been an amendment as to how detex is declared and reported. So the traditional way for declaring this has been the total detex per tuft. For example, 15,200 detex. We are now being asked to declare and provide detex results per fibre or strand in a tuft, and note how many there are of each colour. Again, here we have a worked example of this. So in a standard monofilament carpet with 8 yarns in a tuft, each yarn would be 1900 detex, and there would be 8 yarns. So rather than declaring 15,200 as we previously would have, we're now being asked to declare it as 1900 by 8. The second example there shows a carpet which has 2 different monofilaments of 2 different detex. So again, you would declare 1900 detex by 8 plus 2000 detex by 2, for example. Another recent addition to the manual has been an alternative method for rotational resistance. So the lightweight rotational resistant method, or equipment, utilises a compressed spring to exert the necessary force onto the test foot, rather than the heavy mass which was detailed in the original or standard rotational resistance method. This is a benefit not only in terms of weight saving for travelling, which is obviously important, but also for the well-being of the technicians, who no longer have to carry a 45+ kilo piece of equipment around the field. The accuracy of this method was verified by a round robin that we hosted here at Sports Labs last year in 2019 with some of the other laboratories, whereby a large data set was collected on a range of surfaces and test conditions. The most recent update to the method focused on tightening up the design, and some additional detail was added to the method. As most people will know, the skin friction and abrasion test has been in the FIFA manual for quite some time. However, the latest amendment was implemented to improve repeatability among laboratories and operators. The method for sample preparation was expanded to include removal of excess spin oil by washing and rinsing of the turf, as well as the use of compressed air to clean the skin after the initial skin friction test prior to testing on the Tensile equipment. A new supplier for the skin was also added, as the previous supplier no longer manufactures the skin. In regards to TGAs on infills, these have always been done as part of the product testing, but they were added at the start, or I think at the start of the year, for initial field tests to check that the material supplied to the field complies with is of the same quality as specified. The image here shows where this new requirement can be found within the FIFA handbook of requirements on table 4 of test method 11. There is a plus or minus 15% tolerance on the parameters for TGA compared to what is declared by the supplier. This last slide here just shows a typical TGA curve for an SBR material. As you can see, it details the organic, inorganic and elastomer content of the SBR. Thank you very much for listening to the updates. If there's any questions, as I said, please feel free to give anyone at Sports Labs a shout, specifically myself or Sean or Neil, and we'll be happy to help. I'll now hand back to Neil, who will discuss minimising infill migration on the fields. Thank you very much.
Thank you, Craig. Much appreciated from that, and perseverance with the delay. Microsoft need a bit of explaining to do here. So, although we were talking very much about the lab today, I just want to cover some of the minimising infill migration concerns and some of the documents out there to support people. I'm aware that there's people around the world on this call today, so what we want to do is give you some update to the European level and also the guidance documents out there that can be used. So the first one that I'll just touch upon, because a lot of them are based on this document, is the EN 17519 document. Now this has been sped through the harmonised process with the same working groups, and this document covers a lot of different things, particularly brings identification to how is infill migrating, and then the details on how to get around it. So things like snow removal being carried by maintenance equipment, inappropriate maintenance procedures, inappropriate installation procedures, poor storage of spare material, the top-up material, surface water runoffs and filters in these runoffs, wind dispersion. There's many different reasons, but the information in this document gives a little bit more ideas on how to mitigate from that. There's certain things such as field design, installation of the infill practices, the maintenance, how you go about the maintenance, and particularly for snow clearances, where are the recess areas for that material not to get onto the soils around the pitch, the changing rooms, the detox areas. There's a lot of information there on that type of design guidelines. We as a company, consultancy practice, have already brought a lot of these design changes to our protocols. So some of the facilities that are being realised right now and being installed have them in the design, but that should be available for everyone. And the reason that we touch upon this in FIFA is because part of the FIFA field testing process is for the laboratory to check these. So when we talk about FIFA product updates and where we're going in the future, FIFA have already acknowledged these issues, and when we go to a field, we have to do certain checks on snow removal protocols, maintenance equipment. Is it being carried by the maintenance equipment? Appropriate installation procedures. There's a checklist that we look at, and that's certain things that we have to consider when we don't just check shock absorption and deformation and ball roll. We have to check the design of the field, the perimeter fencing, the decontamination, the boot cleaning areas, and the snow storage areas. So the point of mentioning this is that it's already in the thought process of global governing bodies, and these are guidelines at the moment and for best practice, but please be aware that in the future, some governing bodies might adopt these as protocols and actual enforceable legislation. So thank you for persevering with us today with our internet problems, but we've got our questions and answer session with the guys today, and we've already had quite a few questions come in, which is very, very positive. One of the questions, and I'll open up the floor to Sean and Craig here, is there any way to speed up the UVA? That was from an anonymous person. Is there any way to speed up the UVA?
No, the UVA test is actually very, very detailed in the timescale it needs to run because of the cycles it runs through. So there's no way of really speeding that up because of the cyclic testing it goes through. Unfortunately, yes, 7 months can be quite long and frustrating for some people, but it is to the specification requirements, unfortunately.
Okay, thank you for that one, Sean. The next one we had was, is the max change in breaking force also less than 25% for green reference yarn? So is the max change in breaking force also less than 25% for the green reference yarn?
Yes. Yeah, after UV it applies to all the yarn colours, maximum 25%. In the FIFA requirements now with the 25% from the green value, the initial green value, then by default you should be with below this anyway.
Okay, thank you for that, Sean. The next question is a double barrel one, maybe from the same person, Simon and Oz. What size of sample for UVA is needed, and what size of sample is needed for DSC? So 2 questions there.
Yeah, so for a UVA sample, for UV, we tend to ask for a 3 linear meters of yarn. This is so that we can randomly select test portions from the sample supplied. We try to obviously avoid selecting samples from a small piece of yarn, because if there's any discrepancy in the extrusion of that yarn, then it can affect the UV results. And in regards to the DSC size, it's actually tested on an approximate 7.5 milligram size sample, so it's extremely small. So effectively, 1 tuft from a yarn or a field can be tested for DSC multiple times.
Okay, thank you for that, Craig. The next one's more of a comment. Change to detex is a great addition. I echo that. I think being clear on the number of yarns, equating that to detex is really, really important, particularly for marketing purposes and for people that are procuring and deciding on products. The next question is for you guys, is why did FIFA change the line testing rules? I guess that's probably meaning the coloured yarn testing in the list book.
Yeah, I think that was all done through the technical group that FIFA have, the tag group. There's preferred producers, FIFA laboratory representative, and yarn manufacturer representative, and they reviewed all the results from the line colours and gone through the list sports Excels. So I think they were looking at reducing the amount of requirement for the line colours, and saving on to redo performance testing on the line colours, and actually looking at the yarns themselves to try and highlight if there's any potential issues in the wear of the yarn by UV. Hence the new requirement for the UV to be within 25% of the reference green yarn.
Okay, thank you for that, Sean. The next one we had in, where can we buy the new traction kit? So that's from, you can buy it from Sports Test Equip. There's many different suppliers, but we do that. So if you need to get in touch, just drop us an email. The next one is, do you know of any future changes? Is there anything in the pipeline?
There will be a manual update at some point in the future. I think we're looking at the end of 2021, maybe into 2022. I think there's going to be more requirement for the wear durability on the yarns in the Excel and maybe another device. Also, there'll be some more more biometric measurement device probably potentially to look at interaction between the player and the surface a bit more. I mean, these are all still in research or in discussion at the moment, and nothing's been finalised. So I would suggest that there will be some changes coming up, but the details of which we're not 100% sure of yet.
Okay, thank you for that, Sean. The next one's got one in, is from Carol. Will these new requirements on infill be imposed on all new certifications of installed fields regardless of the turf system? FIFA certified systems prior to these updates, or is it for newly certified systems? I think, I mean, I'll jump in there. I think, Carol, most of it's guidelines at the moment. If they do come in and they're enforced, then we'll deal with that when it happens. But at the moment, there's no enforceable details. It's only guidance. Is that correct, Sean, from your side?
Yeah, it's guidance at the moment.
Okay, next question for the guys. Can a line colour have a different DSC graph compared with the green?
Yes, absolutely it can. You see some yarn suppliers, say for example their green yarns have a less pronounced peak or second peak in their blend yarn than the white or yellow, so it can show as a different DSC shape, although the actual melting points can be very similar, the shape of the graph can be different, so it does show up differently, yeah.
Okay, thank you for that, Craig. The final question we've got in here is whether the potential ban on SBR will mean a pitch built differently, can have its infill removed in the future and then retested to FIFA with cork, for example, in XXX number of years, all SBR would need to be removed. Yeah, I'll quote that question. Yeah, you can remove the infill and then you can add a different type of infill. Whatever you change that system to would have to be tested in the laboratory. So if you wanted to mix that system with different types of infills, then it would have to be tested as a system to get official certification. It's dependent on the enforceable guidelines or the enforceable rules that come in from different levels of governing bodies or European groups. So yeah, it really depends. But whatever you do, you would have to have that system fully certified in the lab before testing it on the field for certification. Okay, I think that concludes today all the questions we've had. There will be a recording of the webinar available to all people that have registered. So if you have any further questions, don't hesitate to get in contact with either Sean, myself, or Craig at a later date. But apart from that, thank you everyone and have a great weekend.